This video is part 3 of my lecture videos on the basic derivative rules, and I'll be concentrating on applications. In the first example, we want to find the equation of a tangent line to this function at the point x equals 2. So it's not necessary to draw a graph, but this is basically an upturning parabola. Looks something like this. And so let's say 2 is right here. We're going to have a tangent line at that point, and we want to find the equation of this tangent line to this graph at that particular point. And so to do this, we first find the derivative. So we're going to find the derivative of the function. The derivative of the function is going to be 6x. That's it. Derivative of 3x squared is 6x. The derivative of minus 5 is 0. Then what we're going to do is we're going to take the derivative, which is 6x, and we are going to evaluate it at the point 2. So we're going to find f prime of 2, which is 6 times 2, or 12. Now, what does the 12 represent? The 12 is the slope of the tangent line. The slope of the tangent line. And so that's what the derivative tells us. And we learned that in a previous lesson, that one of the interpretations of the derivative is that it is the slope of the tangent line at a point. Well, now that we have the slope of the tangent line, we can go to our formula, y minus y1 equals m times x minus x1. This is called the point slope form of a line. And we can use that to find the equation of the tangent line. What we need is we need the slope. We need a y sub 1 and an x sub 1. Well, we can use 2 as the x sub 1. So what I need to do is I need to find out what the function value at 2 is. So that is 3 times 2 squared minus 5. So that's 4 times 3 is 12 minus 5 is 7. And so that is basically the y value. Okay, so y equals 7. The function value is the y value. So we have y minus 7 equals the slope, which is 12, times x minus the x of 1 is 2. And now we just want to, this is an equation of a tangent line, but let's write it in slope-intercept form. So I will have y minus 7 equals 12 times x minus 12 times 2. And then add the 7 to the other side, 12x, and negative 24 plus 7 would be a negative 17. And there is the equation of the tangent line in slope-intercept form. That is slope-intercept form. It doesn't say to put it in that form, but that's always a good way to write it. Another one of our interpretations of the derivative is instantaneous rate of change. So the power generated by a particular windmill is given by this function, P, which is power, in terms or with respect to V, which is velocity. Estimate the instantaneous rate of change of power with respect to velocity when the velocity is 8.3 miles per hour. So what we want to do is we want to find P prime. In other words, the derivative of this function. So that is going to be 3 times 0.021. So we can do that on our calculator. 3 times 0.021. And so that's going to be 0.063. 0.063 times v squared. Well, there's our derivative. And now we just need to evaluate that derivative at 8.3. So we have 0.063 times 8.3 squared. And so we're going to have 8.3 squared times 0.063 is 4.34. And once again, I'm just going to check the arithmetic on that. I always want to make sure I don't make any silly arithmetic mistakes. That looks good. So that is the instantaneous rate of change of power with respect to velocity at 8.3. The next problem is also an instantaneous velocity problem. And we learned in a previous lesson that velocity is the derivative of the position function. So this is what we call a position function. It's s of t, the position at time t. And velocity, the velocity function, is the derivative of the position function. So the instantaneous velocity means we have to find the derivative of the position function. So 2 times negative 16 would be negative 32t plus 90. That is my velocity function. That will give me instantaneous velocity at some point. And so I want to know what the instantaneous velocity is at 2 seconds. So we simply evaluate this at 2. Negative 32 times 2 plus 90 is a negative 64 plus 90, which is going to be what, 26. So the instantaneous velocity at time 2 is 26. And I believe that is it for this video.